The first law states that the limit of a is that a constant. This is illustrated by the limit of c as x approaching a is equal to c. For example, we will find the limit of 5 as x approaching 4. In this function, since 5 is constant, the answer will be itself. Here are other examples. The limit of 14 as x approaching 5 is equal to 14, since 14 is a constant value. The limit of 10 as x approaching 11 is equal to 10. Lastly, the limit of 2 as x approaching 1 is still equal to 2. Basic, right?
Let's now move to the second law, the limit of the identity function.
This is illustrated by limit of a as x approaching a is equal to a.
This is somehow similar to the first law, but the difference is that the values of the limit and the x approaching are the same. For example, the limit of 4 as x approaching 4 is equals to 4. Other examples are as follows. The limit of 8 as x approaching 8 is equals to 8. The limit of 20 as x approaching 20 is equal to 20. The limit of 14 as x approaching 14 is still 14.
The third law is the limit of a constant c times a function is equal to the constant c times the limit of the function, provided that limit of f of x as x approaching a exists. This is illustrated by the limit of c multiplied by f of x as x approaching a is equal to c multiplied by the limit of f of x as x approaching a. To better understand this, let me give some examples. The limit of 4x as x approaching 2 is equal to 4 times the limit of 2 as x approaching 2. Simplify the equation. 4 times 2 is equals to 8. Another example. The limit of 10x as x approaching 0. Follow the given steps and simplify. 10 multiplied by 0 is equal to 0. If you want an easy way to do this, just substitute the value of x approaching to the given function. For example, the limit of 5x as x approaching 5 will be 25, since 5 multiplied by 5 is equals to 25. The limit of 100x as x approaching 1 will become 100 times 1. 100 times 1 is equals to 100.
The fourth and fifth laws are similar to each other. The limit of the sum or difference of two functions is equal to the sum or difference of the individual limit, provided that the limit of each function as x approaching a exists. This is illustrated by the limit of f of x plus or minus g of x as x approaching a is equal to the limit of f of x as x approaching a plus or minus the limit of g of x as x approaching a. For example, the limit of x squared plus 6 as x approaching 2. Let us follow the illustration a while ago. The limit of x squared as x approaching 2 plus the limit of 6 as x approaching 2 will be 2 squared plus 6. 4 plus 6 is 10. Another example. The limit of x minus 1 as x approaching 5 will become the limit of x as x approaching 5 minus the limit of 1 as x approaching 5. 5 minus 1 are 4. For an easier way, just substitute the value of x to the given function. The limit of 2x minus 5 as x approaching 1 will be 2 times 1 minus 5. 2 minus 5 is negative 3.
Let's now move on to the sixth law, wherein the limit of the product of two functions is the product of their limits, provided that the limit of each function as x approaching a exists. This is illustrated by the limit of f of x times the limit of g of x as x approaching a. For example, the limit of x times 5x plus 4 as x approaching 3 is equal to the limit of x as x approaching 3 times the limit of 5x plus 4 as x approaching 3. Simplify your equation. 3 times 5 times 3 plus 4 is equal to 57.
The seventh law states that the limit of the quotient of two functions is the quotient of their limits, provided that the limit of the divisor is not equal to 0, and the limit of each function exists. This is illustrated by the limit of fx divided by the limit of gx as x approaching a. Example: the limit of x plus 5 divided by x plus 3 as x approaching 2 is equal to the limit of x plus 5 divided by the limit of x plus 3 as x approaching 2. 2 plus 5 is equal to 7, while 2 plus 3 is equal to 5.
The eighth law is all about the limit of nth power of a function is equal to the power of the limit of that function, provided that n is a positive integer and the limit of f of x as x approaching a exists. This is illustrated by the limit of f of x with nth power as x approaching a is equal to the other limit of f of x with nth power as x approaching a. For example, the limit of 3x plus 4, where nth is 3 as x approaching 1, is equal to the limit of 3x plus 4, where nth is also 3 and x is also approaching 1. Follow the steps earlier. The x in 3x will become 1 because you have to substitute x to the value of the x approaching function. So, the answer to that is still 3. Add 4 to 3 will be equal 7. Since the nth power of a function is both equal to 3, the nth power will be also 3, then the final answer will be 343. Another example, the limit of 4x plus 9, where the nth is equal to 2, as x approaching to negative 3 is also equal to 4x plus 9, where the nth is equal to negative 3 as x approaching to negative 3. Distribute the given x approaching function to 4x plus 9, then the answer will be negative 3. Since the nth power of a function is both equal to 2, then the nth power will be also 2, then the final answer will be equal to 9.
The ninth law is all about the limit of the nth root of a function, which is equal to the principal nth root of the limit of that function, provided that n is a positive integer and that the limit of the function is positive if n is even. This is illustrated by the limit of n square root of f of x as x approaching to a is equal to n square root of limit f of x and x approaching to a. For example, the limit of the cube root of x squared plus 4 is equal to the cube root of limit of x squared plus 4 and x is approaching to 2. Follow the steps earlier. The x squared will become 2 squared because you will have to substitute the x to the value of x approaching function. So the answer will be 4. Add 4 plus 4 and the answer will be the cube root of 8, which is equal to 2. Another example is the limit of the cube root of x squared plus 48 and x is approaching to 4. X squared will become 4 squared, therefore the answer will be 16. Adding 16 and 48 will give us a cube root of 64, which is equal to 4.
The 10th law is all about the inequality of f of c of the function to the limit of a function. The limit of a function is not always equal to the value of f of c of the function. If the function is polynomial function, then f of c equal limit f of x. The limit of a function is not dependent on the value of the function. Example, the limit of f of x is equal to x squared minus 4 over x minus 2, where x is approaching 2. If you distribute the x approaching function to this given function, the answer will become 0 over 0. However, if limit x squared minus 4 over x minus 2 where x approaching 2 is not directly distributed to the given x approaching function where you first start it by factoring the denominator, the final answer will be 4.
And that ends our discussion about the limit laws. Before we end this video tutorial, let us first answer some exercises.